Section 200.7 C1 of the National Electrical Code, specifically the 2014 edition, prohibits the use of white or grey conductors for anything other than grounded neutral conductors, with a few exceptions. These exceptions include firstly, two-wire branch circuits identified by three-wire methods for future use, such as two-wire plus ground. Secondly, in standard 120 volts, branch circuits that do not carry more than 15 amps. Thirdly, in circuits where the grounded neutral is not re-identified at outlets. The rationale behind this code requirement is to prevent the misidentification of neutral conductors. Misidentification can create significant electrical shock hazards and potentially cause equipment damage. By restricting the use of white or grey wires exclusively for grounded neutrals, electricians can readily identify neutral conductors. This ensures they are connected to the correct terminals, minimizing the risk of errors. Installing multiple neutrals with different colored stripes into the same panel is a direct violation of the National Electrical Code and can result in several adverse consequences. Firstly, it poses electrical shock hazards. If neutral conductors are misidentified and connected to live terminals, it creates a dangerous situation for anyone interacting with the electrical system. Secondly, equipment damage is a significant risk. Overloading or disconnecting neutral conductors can lead to malfunctions and damage to connected equipment. Thirdly, failed electrical inspections are a certainty. Electrical inspectors will mandate strict compliance with the National Electrical Code. Any violation will result in a failed inspection until the issue is rectified. To further clarify the importance of proper neutral identification, consider the function of the neutral conductor in an electrical circuit. In a standard alternating current or AC circuit, the neutral conductor provides a return path for current back to the source. It is typically grounded at the service entrance to ensure that the electrical system is at a 0 volts potential relative to the earth. This grounding is crucial for safety, as it helps to prevent voltage buildup on conductive surfaces, which could lead to electrical shock. When multiple neutral conductors are present in a panel and not properly identified, it becomes difficult to ensure that each circuit has a dedicated and properly grounded neutral return path. This can lead to imbalances in the current flow, which can overload neutral conductors and cause them to overheat. Overheated neutral conductors can melt insulation, create fire hazards, and damage connected equipment. Furthermore, misidentification of neutral conductors can lead to accidental connection of a neutral to a live terminal. This can energize the neutral conductor, creating a shock hazard for anyone who comes into contact with it. In addition to the safety and equipment damage risks, violating the National Electrical Code can also have legal and financial consequences. Electrical contractors who violate the code may be subject to fines, penalties, and even loss of their license. Homeowners or business owners who have electrical systems that do not comply with the code may be required to make costly repairs to bring the systems up to standard. Therefore, it is essential to always follow the National Electrical Code and ensure that all electrical work is performed by qualified and licensed electricians. In the context of the specific question about installing multiple neutrals with different colored stripes into the same panel, it is important to understand why this is a violation of the code. The purpose of using white or grey conductors for neutral conductors is to provide a consistent and easily recognizable identification system. When different colored stripes are added to neutral conductors, it can create confusion and make it difficult to distinguish between different neutral circuits. This can lead to accidental misconnections and the potential for electrical shock or equipment damage. For example, imagine a situation where an electrician is working on an electrical panel and needs to disconnect a neutral conductor. If the neutral conductors are all white or grey, the electrician can easily identify the correct conductor to disconnect. However, if some of the neutral conductors have different colored stripes, the electrician may accidentally disconnect the wrong conductor, which could interrupt the power supply to other circuits or create a shock hazard. To avoid these problems, the National Electrical Code requires that neutral conductors be identified by their white or grey color and that they not be used for any other purpose. This ensures that electricians can easily identify neutral conductors and avoid making mistakes that could lead to safety hazards or equipment damage. In addition to the color coding requirements, the National Electrical Code also specifies how neutral conductors must be sized and installed. Neutral conductors must be sized to carry the maximum unbalanced current that could flow in the circuit. This is to ensure that the neutral conductor does not overheat or become overloaded. Neutral conductors must also be properly grounded at the service entrance to provide a safe return path for current back to the source. The grounding system must be designed to minimize the voltage potential between the neutral conductor and the earth. This helps to prevent electrical shock hazards in the event of a fault. When working with electrical systems, it is essential to always follow the National Electrical Code and to take all necessary safety precautions. This includes wearing appropriate personal protective equipment, such as gloves and safety glasses, and using properly insulated tools. It is also important to de-energize circuits before working on them and to test circuits to ensure that they are de-energized before beginning work. By following these safety precautions, you can minimize the risk of electrical shock and other hazards. In summary, the National Electrical Code prohibits the installation of multiple neutrals with different colored stripes into the same panel. This is because it can lead to misidentification of neutral conductors, which can create electrical shock hazards and equipment damage. To ensure electrical safety and compliance with the code, it is essential to use only white or grey conductors for neutral conductors and to follow all other applicable requirements of the National Electrical Code. When performing electrical work, always consult the latest edition of the National Electrical Code and follow all applicable safety precautions. If you are not qualified to perform electrical work, it is best to hire a licensed electrician to do the job for you. They have the knowledge, skills, and experience to perform electrical work safely and in compliance with the code. This ensures the safety of yourself, your family, and your property. Remember that electrical systems can be dangerous, and it is essential to take all necessary precautions to avoid accidents. By following the National Electrical Code and using qualified electricians, you can ensure that your electrical systems are safe and reliable. The information provided is for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician before performing any electrical work. Failure to do so could result in serious injury or property damage. Furthermore, always be aware of the specific electrical codes and regulations in your local jurisdiction. These codes may vary from the National Electrical Code and may have additional requirements. It is your responsibility to ensure that all electrical work complies with the applicable codes and regulations. By taking these precautions, you can help to ensure the safety and reliability of your electrical systems. Always remember safety first when working with electricity.